Good day everyone, we are the group 15 and we will be discussing the chapter 15, which is the air pollution, climate change and ozone depletion. And without further ado, let us start. So what is the nature of the atmosphere? Earth's atmosphere is composed of about 78% nitrogen and 21% oxygen and 1% other gases. These gases are found in atmospheric layers defined by unique features such as temperature and pressure. The atmosphere consists of several layers. We live at the bottom of a thin envelope of gases surrounding the Earth called the atmosphere, and it is divided into spherical layers. But before discussing those layers, let us first define what is atmosphere. Atmosphere is a mixture of gases that surrounds the Earth, and it helps make life possible by providing us with air to breathe and shielding us from harmful ultraviolet or the UV radiations coming from the sun, trapping heat to warm the planet and preventing extreme temperature differences between day and night. Always remember that each of the planets in our solar system have an atmosphere, but none of them have the same ratio of gases or layered structure as Earth's atmosphere. And now, let's tackle about the layers of the atmosphere. So the atmosphere has 5 layers, which are the exosphere, the thermosphere, the mesosphere, the stratosphere, and the troposphere. So based on the picture shown in the PowerPoint, the Earth's atmosphere is a dynamic system with various layers, and the average temperature of the atmosphere varies with altitude. So you can see the red line, that's the altitude, and with differences in the absorption of incoming solar energy. Most ultraviolet radiation from the sun is absorbed by ozone, found primarily in the stratosphere in the ozone layer 17 to 26 kilometers or 11 to 16 miles above the sea level. But as of now, let us just focus on the 2 innermost layers of the atmosphere, which are the troposphere and the stratosphere. Troposphere. The troposphere is the atmospheric layer closest to the Earth's surface, and about 75% to 80% of the Earth's air mass is found in this layer. It is the layer which supports life. Next is the stratosphere, which is the second layer of the atmosphere, which contains the protective ozone layer. The troposphere extends from about 17 to about 48 kilometers or from 11 to 30 miles above the Earth's surface. Although the troposphere contains less matter than the troposphere, its composition is similar, with 2 notable exceptions. Its volume of water vapor is about 1/1000 that of the troposphere, and its concentration of ozone is much higher. Much of the atmosphere's small amount of ozone, it is concentrated in a portion of the stratosphere called the ozone layer. It is found roughly around 17 to 30 kilometers or 11 to 19 miles above sea level. And now let us discuss what is ozone layer. So the ozone layer or the ozone shield is a region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. It contains a high concentration of ozone in relation to other parts of the atmosphere, although still small in relation to other gases in the stratosphere. Stratospheric ozone is produced when some of the oxygen molecules there interact with the UV radiation or the ultraviolet radiation emitted by the sun. This global sunscreen of ozone in the stratosphere is about 95% of the sun's harmful UV radiation from reaching the Earth's surface. The emission of ozone-depleting substances has been damaging the ozone layer. Why is the stratospheric ozone called global sunscreen? The stratospheric ozone layer is called as the Earth's sunscreen because it protects living things from too much ultraviolet radiation from the sun. And moving on about the nature of atmosphere, let us now discuss air pollution that comes from natural and human sources. Air pollution comes from natural and human sources. Air pollution is the presence of chemicals in the atmosphere in concentration high enough to harm organisms, ecosystems, or human-made materials or to alter climate. The air pollutants come from natural sources includes dust blown by wind, pollutants from wildfires, volcanic eruptions, volatile organic chemicals released by some plants. And for the human sources of outdoor air pollutants occur in industrialized and urban areas where people, cars, and factories are concentrated. These pollutants are generated mostly by the burning of fossil fuels in power, industrial plants, which is a stationary sources. So stationary sources means any building, structure, facility, or installation which emits or may emit any air pollutants. And other is the motor vehicle, which is a mobile source. So a mobile source air pollution includes any air pollution emitted by motor vehicles, airplanes, locomotives, and other engines and equipment that can be moved from one location to another. Scientists classify outdoor air pollutants into two categories, which are the primary pollutants and the secondary pollutants. So the primary pollutants are harmful chemicals emitted directly into the air from natural processes and human activities, which can be shown in the figure 15. And then the secondary pollutants are some primary pollutants react with one another and with other normal components of air to form new harmful chemicals. So what are the major outdoor air pollutants? The major outdoor air pollutants are carbon oxides, nitrogen oxides and nitric acid, sulfur dioxide and sulfuric acid, particulates, ozone, and the volatile organic compounds or the VOCs. And now let us first discuss the carbon oxides. So the carbon monoxide is a poisonous, flammable gas that is colorless, odorless, tasteless, and slightly less dense than air. Carbon monoxide consists of one carbon atom and one oxygen atom connected by a triple bond. It is the simplest carbon oxides. Next is the carbon dioxide. Carbon dioxide is the fourth abundant component of dry air that is colorless and odorless gas. It is important greenhouse gas that helps to trap heat in our atmosphere. Another is the nitrogen oxides and nitric acid. Nitric oxide is a colorless gas that forms when nitrogen and oxygen gas in air react at high combustion temperature in automobile engines and coal burning power and industrial plants. Lightning and certain bacteria in soil and water also produce nitric oxide as part of the nitrogen cycle. So by the way, what is nitrogen cycle? The nitrogen cycle is a biochemical process through which nitrogen is converted into many forms, consecutively passing from the atmosphere to the soil, to organism, and back into the atmosphere. It involves several processes such as nitrogen fixation, nitrification, denitrification, decay, and putrefaction. In the air, nitric oxide reacts with oxygen to form nitrogen dioxide. Collectively, nitric oxide and nitric dioxide are called nitrogen oxides. Nitrogen oxide are a family of poisonous and highly reactive gases. These gases form when fuel is burned at high temperature. Some of the nitrogen dioxide reacts with water vapor in the air to form nitric acid and nitrate salt. Both are components of harmful acid deposition. Both nitric oxide and nitrogen dioxide play a role in the formation of photochemical smog, a mixture of chemicals formed under the influence of sunlight in cities with heavy traffic. Nitrous oxide A greenhouse gas is emitted from fertilizer and animal waste and is produced by burning fossil fuel. Another is the sulfur dioxide and sulfuric acid. Sulfur dioxide is a colorless gas with an irritating odor, and about one-third of the sulfur dioxide in the atmosphere comes from natural sources as part of the sulfur cycle. The two other thirds, and as much as 90% in some urban areas, come from human sources. So mostly combustion of sulfur containing coal in electric power and industrial plants, and oil refining and smelting of sulfide ores. So to understand more, let us also discuss what is a sulfur cycle. So sulfur cycle describes the movement of sulfur through the geosphere and biosphere. Example is when sulfur is released from rocks through weathering and then assimilated by microbes and plants. It is then passed up the food chain and assimilated by plants and animals and released when they decompose. In the atmosphere, sulfur dioxide can be converted to aerosols, which consist of microscopic suspended droplets of sulfuric acid and suspended particles of sulfate salts that return to the earth as a component of acid deposition. Sulfur dioxide, sulfuric acid droplets, and sulfate particles reduce visibility and aggravate breathing problems. They can also damage crops, trees, soils, and aquatic life in lakes, and they corrode metals and damage paints, paper, leather, and stone on buildings and statues. And they are a major component of the Asian brown cloud. Asian brown cloud is a layer of air pollution that recurrently covers parts of the South Asia, namely the northern Indian Ocean, India, and the Pakistan. So next is the particulates. Particulates, or the suspended particulate matter, or SPM, consist of a variety of solid particles and liquid droplets, small and light enough to remain suspended in the air for long periods. So according to the Environmental Protection Agency, or the EPA, there are two classifications of particles, which are the fine and the ultrafine. So fine has a diameters less than 10 micrometers, and the ultrafine has a diameters less than 2.5 micrometers. About 62% of the SPM in outdoor air comes from natural sources such as dust, wildfires, and sea salt, and the remaining 38% comes from human sources such as coal burning power and industrial plants, motor vehicles, road construction, and tobacco smoke. Such particulates are a major component of Asian brown cloud. And next is the ozone. Ozone is a gas molecule composed of 3 oxygen atoms. It is colorless and highly reactive gas. It is also a major ingredient of photochemical smog. So there are two kinds of ozone, the bad ozone and the good ozone. Bad ozone is the ozone in the troposphere near ground level. So it is referred to as bad ozone because of its effect on people and environment, and it is the main ingredients in smog. And the other is the good ozone, the one located in the stratosphere. We view ozone in the stratosphere as good because it protects us from the harmful UV radiation, and though both are the same chemical. Much evidence indicates that some human activities are decreasing the amount of beneficial ozone in the stratosphere and increasing the amount of harmful ozone at the troposphere near the ground level, especially in some urban areas. And last but not the least is the volatile organic compounds, or the VOCs, which is the organic compounds that exist as gases in the atmosphere or that evaporate into the atmosphere are called volatile organic compounds, or the VOCs. About a third of global methane emission come from natural sources, mostly plants, wetlands, and termites. And the rest comes from human sources, primarily rice paddies, oil and natural gas wells, and cows, mostly from their belching. Other VOCs are liquids that can evaporate into the atmosphere. And now let's move on to the burning coal produces industrial smog. So when fossil fuels are burned, they release nitrogen oxides into the atmosphere, which contribute to the formation of smog and acid rain. The most common nitrogen-related compounds emitted into the air by human activities are collectively referred to as nitrogen oxides. Industrial smog, consisting mostly of an unhealthy mix of sulfur dioxide, suspended droplets of sulfuric acid, and variety of suspended solid particles that give the resulting smog a gray color, which is why it is sometimes called gray air smog. It is harmful when inhaled because smog irritates our airways, increasing our risk of serious heart and lung diseases. Sunlight plus cars equals photochemical smog. First, let us determine what is photochemical reaction and photochemical smog. Photochemical reaction is any chemical reaction activated by light, and photochemical smog is a mixture of primary and secondary pollutants formed under the influence of UV radiation from the sun. Photochemical smog is a mixture of pollutants that are formed when nitrogen oxides and volatile organic compounds, or the VOCs, reacts to sunlight. It tends to occur more often in summer because that is when we have the most sunlight. Several factors can decrease or increase outdoor air pollutants. So there are 5 natural factors that help reduce outdoor air pollutants. First is the particles heavier than air. Settle out as a result of gravitational attraction to the earth. Second is the rain and snow. It helps cleanse the air of pollutants. Third is the salty sea spray from the oceans. It washes out many pollutants from air that flows from land over the oceans. Fourth is the wind. It sweeps pollutants away and mixes them with cleaner air. And the fifth one is some pollutants are removed by chemical reaction. For example, sulfur dioxide can react with oxygen in the atmosphere to form sulfur trioxide, which reacts with water vapor to form droplets of sulfuric acid that fall out of the atmosphere as acid precipitation. On the other hand, there are also factors that can increase outdoor air pollutants. So there are 6. First is the urban buildings. It slows wind speed and reduces dilution and removal of pollutants. Second is the hill and mountain. It reduces the flow of air in valleys below them and allow pollutant level to build up at ground level. Third is the high temperature, since it promotes the chemical reaction leading to formation of photochemical smog. Fourth is the emissions of volatile organic compounds, or the VOC, from certain trees and plants in heavily wooded urban areas can play a large role in the formation of photochemical smog. Fifth is the grasshopper effect. It occurs when air pollutants are transported by evaporation and winds from tropical and temperate shore areas through the atmosphere to the Earth's polar areas, which they are deposited. This happens mostly during winter. It explains why, for decades, pilots have reported seeing dense layers of reddish-brown haze over the Arctic. It also explains why polar bears, sharks, and native people in remote Arctic areas have high levels of various toxic pollutants in their bodies. And lastly is the temperature inversions. It can cause pollutants to build to high levels. During daylight, the sun warms the air near the Earth's surface. Normally, this warm air and most of the pollutants it contains rise to mix with the cooler air above and disperse the pollutants. Acid deposition is a serious regional air pollution problem. Most coal-burning power plants, ore smelters, and other industrial plants in developed countries use tall smokestacks. Tall smokestacks help to emit sulfur dioxide, suspended particles, and nitrogen oxides high into the atmosphere where wind can mix, dilute, and disperse them. These tall smokestacks reduce local air pollution, but they can increase regional air pollution downwind. The primary pollutants, the SO2 and the NOx, emitted high into the atmosphere may be transported as far as 1,000 kilometers or 600 miles by prevailing winds. During their trip, they form secondary pollutants such as droplets of sulfuric acid, nitric acid vapor, and particles of acid forming sulfate and nitrate salts. These acidic substances remain in the atmosphere for 2 to 14 days, depending mostly on prevailing winds, precipitation, and other weather patterns. During this period, they descend to the Earth's surface in two forms, which is the wet deposition, consisting of acidic rain, snow, fog, and cloud vapor, and the dry deposition consisting of acidic particles. So the resulting mixture is called acid deposition, as shown in the figure, sometimes called acid rain. Most dry deposition occurs within 2 to 3 days, fairly near the emission sources, whereas the most wet deposition takes place within 4 to 14 days in more distant downwind areas. Acid deposition is a regional air pollution problem in areas that lie downwind from coal-burning facilities and in urban areas with large number of cars. Based on the figure shown in the presentation, in some areas, soils contain compounds that can react with and neutralize or buffer some inputs of acids. The areas most sensitive to acid deposition are those with thin, acidic soils that can provide no such natural buffering, and those where the buffering capacity of soils has been depleted by decades of acid deposition. In the United States, older coal-burning power and industrial plants without adequate pollution controls, especially in the Midwest, emit the largest quantities of SO2 and other pollutants that cause acid deposition. Because of these emissions and those of other urban industries and motor vehicles, typical precipitation in the eastern United States is at least 10 times more acidic than natural precipitation is. Many acid-producing chemicals generated in one country are exported to other countries by prevailing winds. For example, acidic emissions from the United Kingdom and Germany blow into the Switzerland, Austria, Norway, and other neighboring countries. Acid deposition has number of harmful effects like damages statues and buildings, contributes to human respiratory disease, can leach toxic metals such as lead and mercury from soils and rocks into lakes used as a source of drinking water. These toxic metals can accumulate in the tissue of fish eaten by people and other animals. Last is the acid deposition harms aquatic ecosystem because of excess acidity. Moreover, acid deposition, often along with other air pollutants such as ozone, can affect forests in two ways. First is leaching essential plant nutrients such as calcium and magnesium from soil. And second is releasing ions of aluminum, lead, cadmium, and mercury, which are toxic to the trees. These two effects rarely kill trees directly, but they can weaken them and leave them vulnerable to stresses such as severe cold, diseases, insect attack, and drought. Mountaintop forests are especially vulnerable to acid deposition because they tend to have thin soils with little buffering capacity and are bathed almost continuously in highly acidic fog and clouds. We know how to reduce acid deposition. According to most scientists studying the problem, the best solutions are prevention approaches that reduce or eliminate emissions of sulfur dioxide, nitrogen oxides, and particulates. Indoor air pollution is a serious problem. In developing countries, the indoor burning of wood, charcoal, dung, crop residue, coal, and other cooking and heating fuels in open fires or in unvented or poorly vented stoves exposes people to dangerous levels of particulate air pollution. According to the World Health Organization or the WHO and the World Bank, indoor air pollution is the world's most serious air pollution problem, especially for poor people. Indoor air pollution is also a serious problem in developing areas of all countries, mostly because of chemicals used in building materials and products. EPA studies have revealed some alarming facts about indoor air pollution. First is the level of 11 common pollutants generally are 2 to 5 times higher inside homes and commercial buildings than they are outdoors, and as much as 100 times higher in some cases. Second is pollution levels inside cars in traffic-clogged urban areas can be up to 18 times higher than outside levels. Third is that the health risks from exposure to some chemicals are magnified because most people in developed urban areas spend 70 to 98% of their time indoors or inside vehicles. According to the EPA and public health officials, the four most dangerous indoor air pollutants in developed areas are tobacco smoke, formaldehyde emitted from many building materials and household products. Third is the radioactive radon-222 gas, which can seep into houses from underground rock deposits. And fourth is the very small or the ultrafine particles. The figure above shows some typical sources of indoor air pollution in a modern home. And next is about body's natural defenses against air pollution can be overwhelmed. Based on the figure shown, we can see that it is a human respiratory system. Our respiratory system has a number of ways to protect us from air pollutions. So the hairs in our nose filter out large particles, and the sticky mucus in the lining of our upper respiratory tract captures smaller, but not the smallest, particles and dissolves some gaseous pollutants. Sneezing and coughing expel contaminated air and mucus when pollutants irritate your respiratory system. In addition, hundreds of thousands of tiny mucus-coated hair-like structures called cilia line your upper respiratory tract. They continually move back and forth and transport mucus and the pollutants they trap to your throat, where they are swallowed or expelled. Prolonged or acute exposure to air pollutants, including tobacco smoke, can overload or break down these natural defenses. Fine and ultrafine particles get logged deep in the lungs, contributing to lung cancer, asthma attack, heart attack, and stroke. Years of smoking or breathing polluted air can lead to our lung ailments such as chronic bronchitis and emphysema, which lead to acute shortness of breath.